We're going to have a look at how the graph of a derivative relates to the graph of the function. At the top here, I have a cubic function, and below it, I have the graph of the derivative. So my derivative function is going to be a quadratic. But what I want to do is I want to look at the key points. So I'm going to look first of all at my maximum and minimum points. So I'm going to look at my point here first of all. Now this is a local maximum. But what happens at a local maximum? My tangent, or the instantaneous rate of change, is 0. Remember, our derivative finds us with the gradient of the tangent, or my instantaneous rate of change. So at that corresponding point, or that corresponding x value, my derivative is going to be 0. Let's look at our other turning point. So here's our local minimum. At this point, my gradient is going to be 0. So at that point, my derivative is also going to be 0. Over here, if I look what's happening, even though my function is negative, what's happening to the tangent? My tangent at this point, oops, dodgy tangent, anyway, is positive. It's going uphill. So at that point, my tangent is very positive. Up here, my tangent is still positive, but it's increasing at a slower rate. So my corresponding derivative is still positive, but it's increasing at a slower rate. So if I look at anywhere in this section of here, up until my turning point, my derivative is positive. It's above 0. Now we're going to look at between our maximum point here and our local minimum point there. What's happening to my function? It's decreasing. So in that whole time, my derivative is negative because my function during that entire time is decreasing. At this area here, it's decreasing at its fastest rate. So my rate of change is its fastest. So my derivative reaches its minimum point. But remember, for that entire time, my function is decreasing. The value is decreasing, so my derivative for the entire time is negative. Now for my last part of my function, after my turning point, my function is increasing, so my derivative is positive. It's steadily increasing at a faster and faster rate, so my derivative, which gives me, once again, my rate of change, is steadily increasing. I know it can all be a bit confusing, but remember, as my function increases, my derivative is positive. It is above 0. So it's showing my function's increasing. As my function is decreasing, my derivative is below 0. So it's decreasing. It might be decreasing at a different rate, but it's still decreasing. At my stationary point, my derivative is 0. Key points to remember, key points to understand. Take your time.